Definitely.
Awesome. Okay, I think we're a couple minutes in, so I think we'll go ahead and get started. So as always, for our patch programs, we do 3 things. We discover, we connect, and we take action. So for our discover, we're going to learn about space and space science. For our connect, we're going to do some of our own space science experiments. We'll create our own paper rockets. We're going to be making constellation projectors, and we will be making art using UV light from the sun. And then finally, we'll do our take action, which is just to share your projects, share some of your new knowledge with your friends and family, maybe even put on a space science show at home to show off everything that you've made. So that's what we'll be doing today. And I think, you ready to get started?
Yep, I'm ready.
So Lauren's here to help me color.
Yay.
So let me switch.
My favorite.
Okay, let's get both of us in here.
This way.
Oh, this way. We gotta go this way. No? Yes? That works. Okay. So she's gonna color. Let me actually get you in more than me. Hello. And I'm gonna read off some rocket facts from the NASA website. So we put a printout of this rocket in the description. So if you printed it out, that's awesome. You can start coloring and you can cut it out. If not, we have it up on the screen next to me, right here.
Yeah.
So if you can freehand draw that, or if you can even put your paper up on the screen and trace it, that'll work too. I think it's a pretty simple rocket design. You might need to ask mom or dad or brother or sister to help you too. But that's the rocket that we're going to be cutting out and coloring. So go ahead and get your markers, crayons, colored pencils out, anything that you have. And Lauren is going to start coloring while I work on giving you some facts about rockets from the NASA website.
And you can create your own rocket too. So if you don't like the design on the rocket that we have, feel free to draw your own.
Yep. Just a flat rocket shape will do. Color, I like green, blue, and purple. It's a very good space theme. I agree. So, what is a rocket from the NASA website? Okay. The word rocket can mean different things. Most people think of a tall, thin, round vehicle. They think of a rocket that launches into space. Rocket can mean a type of engine. The word also can mean a vehicle that uses that engine. So how does a rocket work? Like most engines, rockets burn fuel. Most rocket engines turn the fuel into hot gas. The engine pushes the gas out its back. The gas makes the rocket move forward. And go ahead and work on your rockets while I'm reading them off. Go ahead and color. Take your time. We got lots of rocket facts to get through. Okay. A rocket is different from a jet engine. A jet engine needs air to work. A rocket engine doesn't need air. It carries with it everything it needs. A rocket engine works in space where there is no air, so it can't use air like a regular jet engine because there's no air in space for it to use. There are 2 main types of rocket engines. Some rockets use liquid fuel. The main engines on the Space Shuttle orbiter use liquid fuel. The Russian Soyuz uses liquid fuels. Other rockets use solid fuels. On the side of the Space Shuttle are 2 white solid rocket boosters. They use solid fuels. Fireworks and model rockets also fly using solid fuels. So good to know that what is used for fireworks is also used on big rockets that they use for space. Interesting. Next is, why does a rocket work? In space, an engine has nothing to push against. So how do rockets move there? Rockets work by a scientific rule called Newton's third law of motion. English scientist Sir Isaac Newton listed 3 laws of motion. He did this more than 300 years ago. His third law says that for every action, there is an equal and opposite reaction. The rocket pushes on its exhaust. The exhaust pushes the rocket too. The rocket pushes the exhaust backwards. The exhaust makes the rocket move forward. So that was a lot, so they have an example here to explain that a little better. This rule can be seen on Earth. Imagine a person standing on a skateboard. Imagine that person throwing a bowling ball. The ball will go forward. The person on the skateboard will move too. The person will move backward. Because the person is heavier than the bowling ball will move farther. And we will see this in action with our paper rockets that we're making today. We're going to use air, and it's going to go in one direction with an equal and opposite reaction. Okay, what is next? When were rockets invented? The first rockets we know about were used in China in the 1200s. These solid rockets were used for fireworks. Armies also used them in wars. In the next 700 years, people made bigger and better solid rockets. Many of these were used for wars too. In 1969, the United States launched the first men to land on the moon using a Saturn V rocket. I don't know if that's V or 5. Saturn V rocket. So they were invented all the way back in the 1200s. So rockets have been around for a long time, and we've made a lot of advances. Okay. Next is, how's it coming?
Good.
Going okay?
Yeah, so I'm this far along, and I'm going to color my flower yellow. I like yellow
How's everyone
flowers.
else is coming along? We doing okay? We have enough time? Oh, someone says, Happy Cinco de Mayo.
Happy Cinco de Mayo!
I encourage everyone to go look up the actual history behind Cinco de Mayo. Very interesting. Hold on 1 second. Make sure we're all up and running. Okay. So, the next one is, how does NASA use rockets? Early NASA missions used rockets built by the military. Alan Shepard was the first American in space. He flew on the U.S. Army's Redstone rocket. John Glenn was the first American in orbit. He flew on an Atlas rocket. NASA's Gemini missions used the Titan II rocket. The first rockets NASA built to launch astronauts were the Saturn I, the Saturn IB. I don't know what that stands for in Roman numerals. I didn't know there was a B. The first rockets NASA built to launch astronauts were the Saturn I, Saturn 1B, and the Saturn V. These rockets were used for the Apollo missions. The Apollo missions sent men to the moon. A Saturn V also launched the Skylab space station. The space shuttle uses rocket engines. Interesting. And now Lauren is cutting out her rocket. So once you have it colored, you can go ahead and cut it out.
So you're just going to cut around.
So that you cut out your rocket.
I'll show you when I'm done.
NASA uses rockets to launch satellites. It also uses rockets to send probes to other worlds. These rockets include the Atlas V, the Delta II, the Pegasus, and the Taurus. NASA uses smaller sounding rockets for scientific research. These rockets go up and come back down. They do not fly into orbit. So lots of different kinds of rockets. I did not know that.
Mm-hmm. I didn't know that they use them for fireworks. I think that's pretty cool.
Mm-hmm. Same thing. How will NASA use rockets in the future? New rockets are being developed today. They will launch astronauts on future missions. The new rockets will not look like the space shuttle. These rockets will look more like earlier ones. They will be tall and round and thin. These rockets will take astronauts into space. They will take supplies to the International Space Station. NASA is also working on a powerful new rocket called a heavy lift vehicle. The rocket will be able to take big loads into space. Together, these new rockets will make it possible to explore other worlds. Someday, they may send humans to Mars. Wouldn't that be
Cool.
cool? I hope that happens in our lifetime. People going to Mars.
Maybe it'll be a Girl Scout.
Maybe. That would be super cool.
One of you guys out there watching
yeah.
this is going to be the first woman on Mars. I'm calling it now.
Okay. How's it coming over there?
Good. I am all done. Just finished cutting out my rocket. So this is what mine looks like. I did some blue, some green, some purple, and then I made my daisy yellow.
Awesome. How's everyone else coming in the comments?
Someone said done.
All colored, all cut out. Okay. So I think I'll go back to our live so you can see us a little better.
So make sure you clean up after you're done.
Yes.
Parents will appreciate that.
Okay, so the next thing we have to do for our rocket is make our pipettes. So you have a piece of paper. So I'm going to go ahead and cut it in half. We're going to need, so you can also use straws, but I didn't think people would have 2 different size straws. So we're just going to make them out of paper. We're going to make one a little bit like wider and thicker, so about this, and then we're going to make one a lot thinner. But if you have a straw, feel free to use that as well. One just needs to be thicker than the other. Okay, so let's cut this in half. I'm going to make just cutting paper, right? We don't need to be perfect. Yeah. Okay. So I'm going to make the thicker one first, and I'm just going to roll this up like so, and then I'm going to tape it. Does that look about right? Yeah, I think that's maybe a little bit thinner.
Retaping it just with duct tape?
Yeah. So it's about this thick.
Yeah, so the same thickness is like a bigger size straw. So like a milkshake straw.
Or what is that tea called?
Bubble tea?
Yeah, or boba.
Mm-hmm.
I think they use those thicker straws so you can get those like little boba things out.
Do you want me to cut you some potatoes, please? Does that feel like that thickness?
Some people, oh, you don't. If you don't want to color your rocket, you don't have to do that either. It's up to you.
You can color however you want.
Yeah.
But
Yeah, that's perfect. Yeah. Okay. So we made.
That looks good.
Yeah. Doesn't have to be perfect, just so that it's about this thick, maybe a little bit thinner. So we have that, and then we need to make a thinner one.
Unless you have a thin straw.
Yes, that would work too. Someone said they have glare duct tape.
That's awesome.
I think that's probably about a good width. I probably don't need this much for a thinner straw.
This is going to have to be shorter.
Okay, we can cut this like. Lauren's made these lots of times.
Yes, I love making rockets, and I've done them a bunch of times. So I'm going to help her troubleshoot.
So I have a piece of paper about this, and I'm going to roll it this way and make it much thinner.
So you want this, so the straw that she's making now, the thinner one, you want it to be able to fit inside of this hole. So as long as it's thinner than this one.
That works okay, I think.
I would say maybe a little thinner.
A little thinner? Okay. Let's try that.
And I'll cut a piece of tape. So
You may need an extra hand. This is probably the thinnest I can make it.
Okay. As long as it fits inside here.
So this one's just about this. Does it fit inside there? Yep, yeah. All set. Okay. I'm going to tape that down. And again, they don't have to be perfect, just so that you have two, like tubes.
One that's bigger and one that's smaller.
Yes, correct.
Thickness-wise.
Yeah.
Not length-wise.
Is this a good length?
Yeah, so this is a good length for your smaller straw. The bigger straw, okay, so the one with the bigger hole, that one is going to be attached to the back of your rocket. So this is a little bit too big. You want to make sure that it can fit just on the back side of your rocket without going over. So we're going to cut this to make it a little smaller. Is that okay right there?
Yeah.
And the lighter this is, the better. So if you can use like as little tape as possible, that's the best, because then your rocket will go further.
Is there too much paper?
No, I think that's perfect. It's about the same. Maybe a little heavier than the straw.
And then we're going to tape it onto the back of the rocket.
So
put this down so you can see better.
And we're using duct tape, but I think you can really use any kind of tape if you don't have duct tape.
As long as it can squish you'll see.
Okay. So the most important part, so we're going to be taping this onto the back of the rocket, but the most important part so that your rocket launches is you have to press down on the end so that it closes the hole. I don't know, can you see that on there?
Yeah, you can see it.
So this, make it a little easier. This needs to be closed off. So when you tape it down on the rocket, it's going to be completely shut, so there's no air, there's air only flowing through one side. Does that make sense? Mm-hmm. And then my tape, because it's duct tape, it's a little thicker than the rocket. It went over the edges a little bit, so I'm just going to cut that off. So I'm just going to cut those edges.
Make sure it's nice and tight on the back. The tape is nice and tight.
Right, so if you're looking at this, see how there's the holes open right here? You want to make sure that this end of it's open and this end of it is taped down. So there shouldn't be any air coming through this side of it, just this side.
You might need to put a couple layers of tape.
You're using the thick straw for this. So the thin straw, we're not using yet. So put that one aside. The thick straw should be the one you're taping to the back of your rocket.
All set?
I think that looks pretty good.
Yeah, I think it does too. I'm going to tape this down a little bit more just so I don't get a paper cut on my lip when I blow into that. I think everyone's working on theirs. I don't see any comments coming in. Make sure to share pictures of your rocket when we're all done in the comments. Love to see them. Love to see your designs. Take pictures, send them to us. Okay, so I just taped the top too so that I don't get any paper cuts or anything because I'm going to be blowing into this. So, you have your rocket, you have, we'll call it our launcher,
Yeah.
straw. I'm going to stick one end in so that it fits inside. It's going to be too thick. I don't think so. So just like this, and you're just going to blow.
Woo! Yay! And that's how you launch your rocket.
You want to try?
Yes, I do.
Of
course I want to try.
We're a family, so we can share.
Ready? So you guys can see my rocket. I'm going to launch it up in the air.
Super cute, super fun. If you can get your family to make their own rockets too, you should go in the backyard and you should have a contest to see who can launch their rocket the farthest. Maybe try changing some things, working with the tape to see if you can make your rocket go any farther. I think your rocket might go farther if you gave it a little more weight. So if you put like
more weight on here.
Yeah.
Okay.
So feel free to experiment, see who can go the farthest.
And then if you didn't make one of these but you have your own straw at home, you can use that as well. And the best way to do it with these kind of straws is to do it like straight and then bend this up like towards your mouth and then launch it like that. That one wasn't very good. You might have to give it a couple test tries.
There it goes.
Yeah, take it outside. It's supposed to be nice today, as long as it doesn't rain. Take it outside, see how far you can launch it.
Definitely.
You can have contests with your family to see whose rocket goes the farthest. It's really fun. You can do a lot of different stuff with your rocket.
And if it's not working, it's probably because the air is escaping up here. So you might need to put some more tape up here and really make sure it's down tight so there's no air coming out this side. And that's also Newton's third law of motion. Every action has an equal and opposite reaction. So your action is blowing into the straw, and the reaction is the rocket launching.
Very cool. Pretty cool.
Fun and informative. Okay, so our next activity, we are going to look at some stars. So people have found patterns and shapes in the stars for as long as we can remember. Have you guys ever noticed shapes in the stars? And do you know what these shapes are called? Can someone put in the comments, what are the shapes called in the stars?
Ooh, I know.
What do we call those? They're like patterns in the sky. What would we call those? Shapes and patterns in the sky. Any ideas? We just have a little bit of a delay, so we're going to give you guys a couple seconds. Shapes and patterns in the sky.
Make sure to write in the comments if you know what it is.
Yes.
The word they use. Oh, somebody already said it.
Somebody said the Big Dipper. That's one of them.
Little Dipper.
Yep.
Okay, everyone's
getting
so
it.
everyone's yes.
Yeah.
So the answer is constellations.
Constellations are shapes in the sky. So today we're going to be making our own constellation viewers. If you want, we have some constellations that you can use, or you can make your own constellation. I opted to make my own constellation. It's a smiley face, and we're going to show you how to do that. But before we do, I wanted to show you some images of constellations. There they are. So we have 4 on our screen right here. We have Ursa Major, we have Pegasus, we have Leo, and we have Canis Minor. So Ursa is Latin for bear, Canis is Latin for dog, Canis? Might be Canis. And I believe Leo is Latin for lion, because like canine. If anyone is a Leo, their star sign is a Leo. It's a lion. So that's the 4 we have.
So you can find these in the sky at night made of stars, right?
Yes. So our next thing is that stars make the basic outline of these shapes, but we have to use our imagination to fill in the shape or animal, kind of like a connect the dots drawing. So it's not exactly that shape, but you can use your imagination and kind of fill in the blanks and see how they came up with these constellation shapes and names for them. And a lot of these constellations have stories behind them. From whenever they were discovered, people made up stories about the stars and how they got that way. And I actually have the story of Pegasus. So this is the story of Pegasus.
Yay.
Without further ado. Pegasus was a flying horse. He was the son of Poseidon, the lord of the sea. His mother was the dreadful monster Medusa. She had snakes for hair and hated everyone, including her son Pegasus. Pegasus did not mind that he was born a horse. In fact, he rather liked the power and speed it gave him. People kept trying to kidnap him. After all, he was a horse that could fly. Anyone could see the value of that. Whenever people tried to kidnap him, the gods always got involved. So Pegasus was safe, but lonely. He couldn't live with his father under the sea because Pegasus could not breathe underwater. He did not want to live with his mother. The other horses shied away from him. They knew he was different. He belonged nowhere. He kept himself busy by saving others, especially Greek soldiers wounded in battle. But it was not the same as having a family or a friend to do things with. One day, Zeus, the most powerful god of all the Greek gods, noticed that Pegasus was very sad. That was the day Zeus and Pegasus became best friends. Zeus took Pegasus to live with him on Mount Olympus. Zeus and Pegasus were soon a familiar sight, flying through the stars. Zeus had a friend he could count on and a horse he could ride, and Pegasus had a friend and a home. Their friendship made them both very happy. Aww. So, a lovely story about Pegasus that has been passed on through the generations. So maybe tonight, if you can see the stars, it might be a little cloudy tonight, but anytime you have a clear night, look up and see if you can find Pegasus. You bring him up again. So it'll look like this pattern here. And I don't have Zeus's pattern, but he must be close to Pegasus for that story. So see, next time you have a clear night, if you can look up in the sky and see if you can find Zeus and Pegasus. I think that would be really fun. So, without further ado, our next activity is making a constellation viewer, or your own constellation if you want. So what we'll need is a toilet paper roll. I already have one made. You will need construction paper. The darker the construction paper, the better, but any construction paper will work. Something a little bit thicker than regular paper. A rubber band or tape, either one will work. And a push pin or something to put little holes in the paper. So if you don't have a push pin, I'm sure you can find something to poke holes in the paper. Somebody said tonight or any night. Any night you have a clear night, go ahead and look at the stars and see if you can find any of those constellations. I think there's even apps that you can use to help you find constellations. Oh, that would be cool. So that would be really cool. Okay. So for our constellation viewer, this is what it's going to look like at the end, but I'll take mine apart so you guys can see. So the first thing we're going to do is cut a pretty large circle out of our black or dark colored construction paper. Is that better? So I made a circle, I've already made one, about this big, but I think a little bit bigger might actually be better. So I'll cut one, cut us each one. Is that okay? Yeah. It doesn't have to be a perfect circle either. This is definitely not a perfect circle. It doesn't have to be perfect. Circle, oval, about the size of your head, would you say? Maybe a little smaller. Size of your head might be a little too big. This one's for me? Yes. Thank you. You're welcome. I'm going to make myself one. Oops, sorry. That's okay. Okay, so about this. And then we're going to be folding it over top of our toilet paper roll. And I find that if you cut some slits in the side, it's easier to fold it over. So not too far in, because we don't want to cut into the center. And you don't have to do this. This is optional. But it might help you fold it over. So you can see I didn't cut all the way through the center because we're going to need that to be intact. But I've made some splits in it just so that it's easier to fold over the sides. Does it matter where the splits go? Just all around the outside. You do like 2 at a time though? Doesn't matter. It doesn't matter. Okay. I just put slits all the way around, looks kind of like a flower. And that's not necessary, it's just easier to fold over that way. So we're going to put that on top, and we're going to fold it over. And then you can take your rubber band. Squish it, having some trouble. No, I had some trouble the first time too. You just got to squish it down so it lays flat. So this should be, the paper should be flat against here, right? Yes. Okay. Nice and flat and tight. And then you can put your rubber band over. If you can't get your rubber band to work, tape would work too, or if you don't have a rubber band. Just make sure that it's nice and tight on there. And again, it doesn't have to be perfect. So it looks like this. How's it going?
It's okay. No, I can do it.
I just need a little extra time. Okay. Take your time. Okay. You're right. I should let you do it. Okay.
How's that?
Good? Tight?
Is that good?
Yeah.
So
they look like this.
oh, they're cute.
And then you're going to take a push pin and you're going to push through your paper. Not so hard that it comes undone. You're going to push through to make a hole, and then I sort of wiggle it around a little bit so the hole is big enough for light to get through. So you can make your own constellation, which is what I did for my first one. You can see I made a smiley face, maybe. But we also have, let me show you. So I have this handout in the description above us. So you can feel free to print that out, and you can cut those and tape it over top. And then you can put the push pin in where those black dots are and make an actual constellation to view. But if you're not able to print that out or haven't had it printed out yet, which I didn't, you can make your own constellation, which I think is pretty cool. I made a smiley face, but feel free to make whatever shape you like. If you want to make one of these shapes. But if not, make your own shape. You can even make your own story up about it, like the story of Pegasus, if you're so inclined. But I'm just going to make, I wonder if I can make a letter. Ooh, you could do like the first letter of your name. I was going to do a G for Girl Scouts. So that's a good one. So I'm wiggling it around a little bit so that the holes are big enough that light can get through, because you want light to be able to shine through those holes. Waiting very patiently, thank you.
No problem. I'm thinking of what I'm going to make. I think I'm going to make a heart.
Yeah. You're trying to make a heart?
A
Heart constellation?
Yeah.
So it kind of looks like this. The holes aren't super big, but they're big enough that I can get light to shine through. Let us know in the comments what you guys are making. If you're making a particular shape, or you're just going for it and doing a couple of dots. If you're making a particular constellation, I think it would be super cool if we made our star sign constellation.
Oh, that like Gemini,
yeah.
or
and you could even make like a big one and use it like at night. I think that would be super fun.
I wonder
Like if you had like
a paper towel. No, theirs is pretty small.
Yeah, you can use a paper towel. I have a paper towel holder too. It would be cool if I had like a night light that I could put this over and see it like on the ceiling.
On the ceiling.
You can put, I have a flashlight here, so you can take your flashlight. You guys won't be able to see it, but you can put your flashlight in here. Oh, you can kind of see it.
Oh yeah, you can see it. Is it upside down?
Yes. Let's make it. I don't want to make it too bright. There we go. You can see the G, and then if I put it like up against the wall, I can see it. It'll be backwards. My G is backwards.
Oh no! It's showing though. It's a G.
Yeah. And you can put it against the wall, and you can see the constellation projected up on the wall.
It's pretty cool.
Pretty cool.
I wish we could show you guys. I made a heart.
Can you see it?
Oh yeah, it's
Cute.
Can we put the light?
Someone says they're doing Hercules. That's awesome.
Wow. And it just goes on the back of it? Oh,
yeah.
Like inside of it?
Yeah, inside. And you might have to finagle it a little bit so that you can see it. It's not on.
Oh.
Turn it off. How do you turn it back on? The fancy flashlight. There you go. Thank you. And I think the brighter the flashlight, it might look better. It's not dark enough in here. It would work great, like in the bathroom, like with the door closed, no windows, no light. I might have to get a little closer.
Oh, there it is! Oh, it does look like a heart. Yay!
I wish you guys could see it. I wonder if we do it like there's no way they're gonna be able to see it.
It's too light.
Yeah.
But the closer you get to the wall with the light, the easier it is to see. So if you don't see it, try holding the light in your constellation closer to the wall. Or if it's darker, it would work better if it was darker. But you can also, if you don't have a flashlight, if you just look through it up at the light, you can see it from the inside.
Oh, okay. Oh, yeah.
That's neat. I wonder if you can we put it over the camera and you can see? Yeah. Down a little bit. Yeah.
There's my heart.
Awesome. So you can make actual constellations, so you can view actual constellations right inside if it's too cloudy to see them outside. Or you can make your own constellations. They're pretty neat.
I really like this.
I wonder if you had like a really bright light, if you could get it to like project, or if you made like a big one, like with a bigger tube. And I think the darker your construction paper is, the better, because the light only shows through the holes.
Look,
then.
you can see through here. Look.
You guys see my heart? Super cute. And super simple. So you can also make, if you use a rubber band, you can also make like a bunch of these, and you can take them off and put different ones on. Or if you tape them, you can just get a bunch of paper towel rolls and make a bunch of different ones and tape them on. And if you're going to be doing the actual constellations, you can print that out. You cut that circle out and lay it over top, and then just push the pins through where those black dots are. Pretty fun. Did you enjoy it?
I love it. I want to make more.
Okay. So our last activity, we will be doing an art project with UV light, which is super cool. Who knew that you could use UV light to make art? But before we do that, I have some fun facts about the sun and about UV light. So the sun is a star made of hot, glowing gases. Because of this, there are no hard surfaces on the sun. If the sun were as tall as the typical front door, the Earth would be the size of a U.S. nickel. So it's giant. It's like, it has to be like
In other words,
it has to be like 1,000 Earths. Without the sun's energy and heat, there would be no life on Earth. The temperature at the sun's core is about 27 million degrees Fahrenheit. That's hard to even comprehend. And the sun provides all the energy and heat that make plants grow and keep us warm. So our sun, the sun is actually a star, so there are a lot of suns in the galaxy. Maybe not in our galaxy, in the universe. Mm-hmm. I'm not a scientist. Don't quote me. Our sun shines brightly in the daytime, warms our planet, and helps plants grow. But the sunlight we see with our eyes is only a very small part of the light the sun gives off. Most sunlight cannot be seen with just our eyes. One type of this invisible light is called ultraviolet light, also known as UV. This is the light that gives us suntans and sunburns, which is why it's important to wear sunscreen. So UV light we can't see, but it is there. And we're going to put that to the test. What do you think will happen? We're going to take a piece of construction paper. Any color will work. I had this orange piece I thought was appropriate for the sun. And we're going to take some sunscreen. We're going to put the sunscreen on our hands. I'm going to put one hand. Lauren's going to put another hand. And then we're going to put it down. But what do you think will happen to the construction paper where the sunscreen is versus where the sunscreen is not? And we're linking in the comments. There's some more activities on. This is from NASA's website. And there's a ton of activities and information on their website. If you guys want more, you can check out their website. It'll be linked in the comments below. Ooh, or to the side, depending on how you're watching this. So we're going to get a little messy. I'm going to shake this up. We have 30 SPF. So anything 30, there we go. Anything 30 or higher will work the best. The higher your SPF, the better, because it will protect better. So I'm going to put it on my left hand. Yeah, you can do your hand, or if you want, you can put it on your finger and make a pattern.
Can I do that?
Paint. Yeah, I'm going to make a heart. Okay. It's a heart theme today.
Yeah. I like this. It's the easiest shape. Oh, it smells like summer. I'm so excited for summer. And you don't want to rub it in completely. You want some sunscreen. You can see the sunscreen on your hand so that you can transfer it onto the paper. The paper will change color. Actually, kind of the opposite. That's a great guess. So where the sunscreen is on the paper, you can see my hands covered in sunscreen, maybe. Compared to this hand, turn it sideways. It's hard to see.
Well, there's sunscreen on it.
You don't want it to rub in completely because you're going to transfer it onto your paper. But where the sunscreen is will protect the construction paper from the UV light. So the rest of the paper will kind of get sun bleached from sitting in the sun. But where you put your sunscreen, it will stay protected from that UV light, and it will stay that same color that the construction paper is now. So if you don't believe me, you can try with regular lotion that doesn't have any SPF, and it will not work the same. So I'm going to take my hand and I'm going to put it on my paper. And I think we have an example that we did yesterday. We didn't use construction paper, but hopefully it will work just the same.
The nice thing about this art project is that it smells good.
Unlike some of our other projects.
Yeah, some of our other projects don't smell as good.
I have a towel so I can wipe the sunscreen off of my hands. And I think I'm going to take a little bit more lotion. Can I use that?
Mm-hmm.
And I'm going to sign my name.
You going to show them?
That might not work.
Just do like a big letter S. Or GS for Girl Scouts.
Ooh. You can share lotion. I'm going to do a GS. Thanks.
You're welcome. Samantha from Troop 20253 said paper will change color.
The paper that's in the sun will change color. The paper that is protected by the SPF, that's protected by the ultraviolet, by the SPF, is protected from the ultraviolet light. Oh my gosh. That will stay the same color. It will keep its color because it won't be affected by the sun or the ultraviolet light. Good? Yeah, I think so. You need a towel?
Yeah.
So you can see we did it on a piece of regular paper yesterday. Oh, there you go. You can see Lauren did her hands yesterday. Turned out pretty good. And this is ours today. So we're going to set that out in the sun and let it dry. And where it's protected from the sunlight, those will stay dark. And the rest of it will get a little bit lighter. So they say you should always wear sunscreen even in the winter, because there's those, even though you can't see it, there's still those UV lights coming through that can give you sunburn. So if you're going to be outside for a long time, even in the winter, you should have at least sunscreen on your face. Yes, absolutely. Good point. So that is our last project, but we do have some more true and false questions. I love my true and false questions, so I'm going to ask them one at a time. And again, we're a little bit delayed, so make sure you put the number of the question. So during the first question, put 1 and then put T or F if you think it's true or false. Okay, so number 1. Apollo astronauts collected moon rocks for analysis. Astronauts haven't traveled to Mars to collect rocks, so we don't have any pieces of Mars to analyze. Astronauts haven't traveled to Mars to collect rocks, so we don't have any pieces of Mars to analyze. True or false? I'm going to give you guys a second. True or false? Do we have rocks from Mars to analyze? Do we have Mars rocks, even though we've never been there? True or false?
True or false, we don't have any.
Right. Oh, sorry. We don't have any Mars rocks. Is that true or false? Oh, I see lots of falses. That's question number 1. Yes, you guys are correct. That one is false. We do have Mars rocks on Earth, although they are not plentiful. We, as in NASA, NASA believes that asteroid impacts on Mars cast fragments of it into outer space. Eventually, Earth captured a few of them and they descended onto the surface. Scientists can identify these pieces as being Martian, or from Mars, by comparing their chemical composition to that of the Martian soil. We know Martian chemistry because of analysis that probes and landers have conducted on the Mars material. So I know someone put in there that we have stuff from Mars from the rovers that we sent out there, which is true.
Oh, so we have it from the rovers too.
We know Martian chemistry because of the analysis that probes and landers have conducted.
But the pieces from Mars are because asteroids hit Mars and those pieces flew down to Earth.
Correct.
Okay.
That's
pretty cool.
Yeah.
So we haven't been to Mars, like people haven't been to Mars, but we have pieces of them that have landed on Earth.
Very interesting. Okay, that was the first question. I see some people putting 2 true. I think I confused people.
Yes, you did.
By asking the question so many times. Okay, number 2. So put 2 in front of this one. Sunlight requires nearly 25 seconds to reach Earth. True or false? Sunlight requires nearly 25 seconds to reach Earth. True or false?
False.
False.
Okay, we got one false.
We got one true.
Another
Getting
false.
dicey.
True. False.
Ooh, got a good mix on this one.
False.
False.
True. False.
Yeah, good mix on this one. So, the answer to number 2, sunlight requires nearly 25 seconds to reach Earth. That is false. Sunlight requires 8.4 minutes to reach Earth, which is kind of crazy.
Yeah, it's a long time.
It's pretty far away, so it takes, for the light from the sun to reach Earth, it takes 8.4 minutes. So by the time we're done with this live, we'll be getting the sun that's just leaving Earth now. Or just leaving the sun now. Okay, next question, number 3. Jupiter is more massive than all the other planets in our solar systems put together.
True or false?
True or false? Jupiter is more massive than all the other planets in our solar system put together. Number 3. Are we getting a kitty friend?
Yeah.
Jupiter is more massive than all the other planets in our solar system put together.
And this is question 3.
Yes.
False, a true.
Mix again. False. Another false. What are we thinking?
True.
True.
Pretty good mix again.
Yeah, another mix. True. Okay, the answer to this is true. Jupiter's mass is greater than the combined mass of all the other planets in our solar system. So Jupiter is massive. It's bigger than all the other planets combined.
So if you combined all the planets together, Jupiter would still be bigger.
That is correct.
That's crazy.
It is crazy. Okay. Number 4. Blue stars are much cooler than red stars. True or false?
Blue is cooler than red. True or false?
Blue stars are much cooler than red stars. True or false? That's number 4. True or false? We're waiting for the comments to come in, if you're wondering why we're sitting here.
True. True.
Blue stars are cooler than red stars.
Got a lot of truths.
Lots of truths.
Saying that blue is cooler.
Someone says they think it's true because of the fire.
True. True.
Someone says blue is hotter. So that would be false. Blue
Yes.
stars are cooler than red stars.
Valerie said false. Melanie said false. Ooh, got a bunch of falses coming in now.
I think maybe we read the question weird.
No, you read it right.
Okay. We had a bunch of trues and now a bunch of falses. The answer is false. The blue and blue/white stars are the truly hot ones. The red stars are cool comparatively.
So it's kind of opposite, right? You would think blue means cool and red means hot. But with the stars, it's opposite. The blue ones are hotter.
Yes,
and the red
the
ones
blue
are
ones
cooler.
are much hotter. I mean, the red ones are still hot.
Don't get me wrong.
But they are cool compared to the blue and white stars. Very interesting, which we can't see. I mean, we can see the sun. But the other stars, I don't think we wouldn't be able to tell if they're red or blue. At least not with the naked eye. Okay, next question. Approximately 90% of our galaxy might contain dark matter.
90%.
True or false? 90% of our galaxy might contain dark matter.
This is number 5, right?
Yes, number 5.
There are a lot of surprises on that last one. Because you would think red would be hot and blue would be cool.
Yeah.
Someone said true. That 90% is dark matter.
90% of our galaxy is dark matter.
True.
Any falses out there? Lots of trues. True. All right, I think we'll go ahead and say that that one is true. We believe that we as a NASA, NASA believes that 90% of the galaxy might exist in a form we cannot see. We determined its existence by analyzing stellar motions and realizing that stars wouldn't move as quickly as they do if the only matter in the galaxy was the visible matter. So 90% of the galaxy exists in a form that we cannot see. And they figured this out by analyzing stellar motions and realizing that stars could not move as quickly as they do if the only matter in the galaxy was the visible matter. So stars move as quickly as they do because there is invisible matter or dark matter.
Wow.
Very interesting.
Mm-hmm. So they figured out that there was something that they couldn't see by looking at something they could see.
Yes. Very interesting. Very cool.
Crazy.
Okay, number 6. The moon is larger in surface area than the United States. True or false? The moon is larger in surface area than the United States. That is number 6. True or false?
Someone said true for 6. The moon is larger in surface area than the United States.
Is the moon bigger than the
True.
U.S.? True or false? And we're putting it in the comments where you can get your patch. We're almost done. Got a couple more minutes. We got one more true and false question after this.
So a couple said false, mostly trues.
Some trues.
True, mostly
yeah,
true.
I think mostly trues. A couple of falses.
True.
And the answer is true. The moon's surface is almost equal to the combined surface area of both North and South America. So North America meaning U.S., Canada, and Mexico, and then also South America would make up the size of the moon. Interesting.
So pretty big.
Yeah, still very big. 2 continents. Okay, last question, number 7. Of the 4 inner planets, Mercury, Venus, Earth, and Mars has the coolest surface temperature.
Mars, which is the farthest away from the sun, has the coolest surface temperature. True or false? Mars is the coolest. True or false? And this is question 7. So just make sure you put a 7 in front of your answer so we know which question you're answering. And don't leave us just yet. I know we're about to hit 2 o'clock, but we are announcing the winners of our contest for you guys sending in your pictures. The winners of people who have won free patches, and we have one winner who won a $25 gift card. So we'll be announcing that right after this question.
I've seen kind of a mix of true and false so far.
A couple mixes.
One big false.
7 true,
false. So another mix of true and false.
Yeah.
These questions are really hard. They're trick questions.
They are. Which I asked Lauren these questions before I did this, and she got them all right.
I love space.
I would never have gotten them all right, but she did. I'm very proud.
I think space is interesting.
It is interesting. Okay, so number 7. Of the 4 inner planets, Mercury, Venus, Earth, Mars, and they do go in that order. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto? Question mark? Somebody tell me if Pluto's considered a planet these days.
I had some people in the beginning said yes, it was.
Okay, good. I approve. Okay. So 4 inner planets, Mercury, Venus, Earth, and Mars. Mars, which is the farthest away, has the coolest surface temperature. And that is false. Surprisingly, all the 4 inner worlds, the coolest surface is Mercury, which is actually the closest to the sun. It rotates once every 60 Earth days and has hardly any atmosphere. So when it turns away from the sun, it radiates its heat into space, and its surface temperature plunges to less than 200 degrees below zero. So negative 200 degrees is Mercury, which even though it's the closest to the sun, because it doesn't have an atmosphere, all the heat escapes when it turns away from the sun, which makes it very cold. So Earth rotates once every day, and it takes Mercury 60 Earth days to rotate once, so to spin in a circle. I'll give you an example. So you be Earth, I'll be Earth. So every 24 hours, it does a whole spin. But it takes, so every 60 times the Earth does that, Mercury does it once. Yes, correct. So it's like nighttime there for 60 days.
There's people laughing.
I just wanted to give you an example. So surprisingly, that is false. The planet that's closest to the sun is actually the coolest because it has no atmosphere and it has 60 days of nighttime. Okay, so that completes our fun patch.
Yay!
Don't leave yet. I have an announcement of all our winners who won patches for sending in pictures of them doing our virtual patch program. But that is it for our rocket launch space science fun patch. And we'll link in the comments the form that you fill out to get that patch. But I want to go ahead and announce our winners. So we have, I think, 10 winners of a free patch, and we have 1 winner of our $25 gift card. So the winners of our patches for basic first aid is Lily S. For fairy gardening, it is Mercedes Y. For emergency preparedness, it is Megan S. Leave No Trace is Zoe N. Keep Calm is Brooke M. Also Keep Calm is Aaliyah B. and Aubrey M. The duct tape fashion, we have a couple. We have Brianna K., Grace S., and Brooke M. So those are the winners of our free patches, and we have your emails, so we'll be reaching out to you with how to get those patches to you. We'll be mailing them out. And
how did they win those patches, just so everyone who's watching knows?
They won those patches by sending in pictures of them working on these live programming,
Okay.
Which is done now that unfortunately our contest has now ended. We have our winners.
Okay.
So they won't be, please still send in lots of pictures. We love to see what you guys are doing, but that is our patch winners. And then we have 1 winner of our $25 gift card. Drum roll, please.
is Addie M. Addie M has won the $25 gift card for sending in pictures of her doing our live patch programming. So thank you so much to everyone who joins our lives all the time. For everyone, maybe this is your first one. Thank you for joining us, taking the time out of your day to do one, and for sending in all your lovely pictures. We really appreciate it, and it really lifts our spirits.
Yeah.
Seeing all the amazing pictures that you guys send in. So thank you for coming today. Thank you for participating in our contest.
Thanks for having me.
Of course, my pleasure. It's so nice to have someone else. I'm going to have to rope her into doing more with me. Yeah, just thank you guys so much, sending in your pictures, for just joining us and participating. We're so happy to hang out with you guys every Tuesday and Thursday. And Thursday we will be doing, it will be at 6:30 to 7:30, we're doing a She and Me fun patch. So we're doing a little special one for Mother's Day, because Mother's Day is this coming Sunday.
Yay.
So it won't be me, it will be my friend Amber. She will be doing our She and Me virtual patch program, but that is Thursday at 6:30. So we hope to see you guys then. Thanks, everyone.
Bye.
Have a good rest of your day. Bye, guys.